Hi, we are the HSTEM Enterprise Supported Treadmill Group. I am Nathan Luczak, and my teammates are Magen and Tyler. To start off, there is a need for supported treadmills. A supported treadmill is a system for people who are in rehabilitation and that require locomotion training and progressive overload. And this technology exists, but we wish to improve upon it and make it more accessible, especially in the local area. So, to begin, our problem statement is to design and develop a system to take a certain percentage of the user's weight off to aid in rehabilitation. And the main use scenario would be that it fits around a pre-existing treadmill to be used in either clinical scenarios or an at-home scenario. Our motivation statement is to make it affordable and accessible to local health clinics and individuals. Moving on, to start with our project, we had to define a list of objectives and constraints. This would help us be able to mark progress and to show our results. It also helped us focus in on the tasks that we wanted to accomplish along the way while we were designing, prototyping, and building the body weight supported system. So, in the early parts of the project, we defined a list of objectives and constraints that we wish to see and have in the project. And then after we went through and made that list, we quantified each and every one of those objectives. Some of these examples include affordability, which we set a hard number to the dollar amount that we wanted to hit, the weight reduction amount that we wanted to hit, safety factors, and a few other objectives as well. This helped us really build a groundwork for the project and where we wanted to go. It also, along the way, has helped aid us in being able to define and recenter ourselves once we're in the middle of our project.
We opened ourselves up to a variety of design ideas. We considered all areas of the medical field and looked into interesting potential missing gaps in the market that would interest us. Researching into pre-existing medical-grade devices was also a part of our brainstorming stage, seeing what exists now on the market and investigating any specific gaps that we believed we could participate in and fill. Once we found a subject we wished to concentrate on, we narrowed down our search on what specific model we wished to adopt for our own project, and broke our own sub-team into specific parts of the project, between designing a harness, putting together a frame for our support, and making the electrical design board. Some design roadblocks were met along the way, of course, and we will discuss in further detail now. After conducting our research concerning harnesses, we began formulating the best way to ensure the user was as comfortable as possible, while also not restricting their movement. We took inspiration for harnesses from just about everywhere, including harnesses we saw in clinics we had spoken with, to floaty devices used for infants. Our main criteria when it came to constructing harness was ensuring that the harness was not terribly constricting to the user, and that it could aid in lifting an appropriate amount of weight, and that the design was diverse in its sizing. Our initial design included a harness that was inspired by a climbing harness that we had previously tested. We designed a prototype that would support the legs significantly, but it was not until we completed the prototype and we were able to physically put it on and assess its comfortability that we realized the material we were using didn't interact how we wanted it to, and the prototype was not stable enough to stay in one place. We believed the first prototype wouldn't really reduce pinching in the leg area either, as it was designed much like a climbing harness we had previously tested. So, in our next design, we opted to create a prototype that could lift the user from the chest area and would leave the legs open to more movement. Now we will talk about a few initial designs we researched into.
The first design we came across was one with an underwater treadmill so that the water would help ease the stress on the user's lower joints. The second design was a similar one where it had like a compression chamber where air would be put in instead of water. and that was attached to like a harness around the user's waist to similarly reduce stress on the user's lower leg joints. And the design that we eventually went with and wanted to implement was kind of a frame that was attached to a harness that would go around the person's midsection to lift up their body and reduce some of the stress on their lower leg joints again. So here's our first idea for that design. It's very complicated, has a lot of just placeholders, generally not very pretty design. Then we went through and we modified it. We made it a bit more refined, simplified a lot of aspects of it. And here you see the frame. We actually ordered the parts and put it together, and now we have this frame that can be used for our 1/4 scale model to make sure that everything works the way we intend it to. And as this was going on, we also had a team working on the electrical side of things. They designed an electrical control board to control the motor and eventually an interface with the user or the clinician involved in the rehab. We also did some dynamic model analysis to ensure that we are using the proper materials, the proper motor, the gearbox, and everything was all as we needed them to be. So moving forward, we want to finish and test our scale model, our 1/4 scale model, the frame that you saw earlier. And we want to use the information we gather from that to develop our final model, which we have a representation of right there. And we also want to add some features and improve current features, ideally to make a user interface or a much more user-friendly experience. And we also want to contact some potential sponsors. It's really nice to work on things, but we also need funding so that we can purchase materials, that we can pay for equipment and other things.
Thank you for listening to our presentation. If you have any questions or comments, please feel free to contact us, and we thank you for your time.